This is differential equations, section 2.4. We're going to do activity 241 in 4 parts. This is part 1, where we tackle part A of the activity. Coming from you on March 26th from my dining room while the kids are hopefully napping and Heidi is reading a book on the front porch. Must be nice. Now, we're going to start. These are called partially coupled systems because you have one equation that has the derivative only is in respect to itself, whereas the other equation is coupled. And the way to solve this is to notice that one of the equations, this one, is separable, and the other one is exact once you substitute for x. So let's begin. So when x prime equals negative x, that means dx dt equals negative x. So that means dx over x equals negative dt. Let's integrate both sides. That gives us natural log absolute value of x equals negative t plus c, and then take e to the power of both sides. And then I get absolute value of x equals, and then I make that e to the c times t negative t. And then I'll make e to the c a new constant, which I'll just call c because I don't care about that last constant. And then I'll let it swallow up the absolute value, so it's just x equals c times e to the negative t. Now, let's deal with y. So I can substitute, and let's move the 3y to the other side. So y prime plus 3y equals, and then instead of x, I'll put c e to the negative t. Now, when I do this, I'm going to get another constant. So let's call this c1. And from now on, I'm no longer going to let constants swallow up stuff, keep changing, whatever, because I've set c1. So c1 is here. And so any sort of changes that happen with c1, I will keep track of. Now, I've got a 3 there, so that means my integrating factor is e to the integral of that, so that's just 3t. And so then y, hopefully if you don't mind, I'm going a little fast there, because by now you should be pretty good at exact equations and figuring out the integrating factor. So there's the integrating factor, so then y equals e to the negative 3t times the integral of c1 e to the negative t e to the 3t, which of course that's e to the 2t. So let's rewrite that. Y equals e to the negative 3t times the integral of c1 e to the 2t dt. Okay, let's integrate. So y equals e to the negative 3t times quantity c1 times 2 e to the 2t plus a constant, which I will call c2. Okay, so then y equals 2 times c1, and then e to the 2t times that would be e to the negative t, and then plus c2 times e to the negative 3t. Okay, so I kept that constant is the same as that constant. And so it's important to not let it swallow up any 2's or anything like that. So then that is my final answer. That completes part A.